Hello everyone, this is Nirali Patel from New Alja Institute of Engineering and Technology. In today's lecture, we are going to discuss about exponential distribution. So let's get started. So a continuous random variable capital X is said to follow exponential distribution if its probability function is given by f of x is equals to lambda e raised to minus lambda x when x greater than 0. But if the value of x is less than or equals to 0, then that time the probability function is given with the value 0. Here, the lambda greater than 0 is called the parameter of the distribution. Exponential distribution is used when the time is unknown until or you want to calculate the amount of time until some specific event occurs. For example, the amount of time between two car arrivals. Now, let's see the memoryless property of the exponential distribution. So, the exponential distribution has a memoryless property, or we can say the forgetfulness property. This property indicates that the distribution is independent of its parts. That means whatever the future happening of an event has no relation to whether or not this event has happened in the past. According to this property, we can say that if x is exponentially distributed and s and t are two positive real numbers, then the p of x greater than s plus t, given that x greater than s is equals to p of x greater than t. Now let's see some constant regarding the exponential distribution. So the mean of exponential distribution is given by e of x is equals to 1 upon lambda, while lambda greater than 0 is nothing but the rate of the change. Variance of exponential distribution is given by 1 upon lambda square, and the standard deviation is nothing but that is the square root of the variance. So that is given by under root 1 upon lambda square, that is equals to 1 upon lambda. Now let's see some example for the exponential distribution. So first example is that a power supply unit for a computer component is assumed to follow an exponential distribution with mean life of 1200 hours. So over here, the mean life is 1200 hours, and as we have discussed, the mean of exponential distribution is given by 1 upon lambda. So we can say that the mean e of x is equals to 1 upon lambda, and that is equals to 1200 hours. And from that we can get the value of lambda, that is 1 upon 1200. What is the probability that component will survive more than 1500 hours? So P of x greater than 1500. So that is given by minus infinity to infinity f of x dx. Now, in order to get the value of f of x, that is the probability density function for the exponential distribution, is given by lambda e raised to minus lambda x for the x greater than 0. So lambda is 1 upon 1200, e raised to minus 1 upon 1200 x. So here we can put the value of f of x, and here we want the probability of x greater than 1500. So we can write integration from 1500 to infinity 1 upon 1200 e raised to minus 1 by 1200 into x dx. Now 1 upon 1200 is constant, so that we can take out from the integration. E raised to minus 1 upon 1200 x dx. Now the integration of e raised to minus 1 upon 1200 x is equals to nothing but that is e raised to minus 1 upon 1200 x upon minus 1 upon 1200. And upper limit is infinity and lower limit is 1500. So 1 upon 1200 upon 1 upon 1200 into e raised to minus 1 upon 1200 x, upper limit infinity and lower limit is 1500, and minus is as it is, and this is going to be cancelled. So minus e raised to minus infinity plus e raised to minus 1500 upon 1200. Now e raised to minus infinity is 0. So e raised to minus 1500 upon 1200, that is e raised to minus 1.25, and that is equals to 0.2865. Now moving to the next example, the daily consumption of milk in excess of 20,000 gallons is approximately exponentially distributed with mean 300. So over here, E of x is 1 upon lambda, and that is equals to 300,000. So lambda is equals to 1 upon 3000. So from this, we can make the probability function f of x lambda e raised to minus lambda x for x greater than 0, otherwise that is the 0. So 1 upon 3000 e raised to minus 3000 into x for x greater than 0. The city has a daily stock of 35,000 gallons. What is the probability that 2 days selected at random, the stock is insufficient for both days? So let's first find out the probability that the stock is insufficient for given day. Or for one day. So since over here the daily stock of milk is 35,000 gallons and the daily consumption of milk is 20,000 gallons, so probability is given as probability x greater than 35,000 given that daily consumption is greater than 20,000. So from the memory list property, this is your h plus t and this is your s. So that is equals to p of x greater than t, and that is equals to nothing but p of x greater than 1500. Sorry, 15,000. Now p of x greater than 15,000 is nothing but that is integration from 15,000 to infinity f of x dx. So that is equals to integration from 15,000 to infinity. The value of f of x is 1 by 3000 e raised to minus lambda is 1 by 3000. So over here minus 1 by 3000 x minus 1 by 3000 x dx. So that is equals to integration from 50,000 to infinity, and 1 by 3000 is out of integration as it is the constant, e raised to minus 1 upon 3000 x dx. So 1 by 3000 integration of e raised to minus 1 upon 3000 x is e raised to minus 1 upon 3000 x upon minus 1 upon 3000. Upper limit infinity and lower limit is 15,000. So 1 by 3000 upon 1 by 3000 e raised to minus 1 by 3000 x. Upper limit is infinity, lower limit is 15,000. 1 by 3000 is cancelled. Over here there is a sign of minus. So e raised to minus infinity plus e raised to minus 5. So that is equals to e raised to minus 5. Now this is the probability that stock is insufficient for 1 day, but they ask for the stock is insufficient for the both days if we are selecting 2 days. So that is equals to, so the probability that stock is insufficient for given 2 days is equals to e raised to minus 5 into e raised to minus 5. So that is equals to e raised to minus 10. So this is your final answer. Now moving to the next distribution, that is the gamma distribution. A continuous random variable capital X is said to follow gamma distribution if its probability function is given by f of x lambda raised to r upon gamma r into x raised to r minus 1 e raised to minus lambda x when x greater than 0. Otherwise, its probability function is given by value 0. Over here, gamma r is gamma function, and that is given by 0 to infinity e raised to minus x, x raised to r minus dx with gamma r is equals to r minus 1 gamma r minus 1 for r greater than 1, and r is equals to r minus 1 factorial for r positive integer. Over here in this gamma function, this lambda and r is the parameter. Lambda is a scale parameter and r is a shape parameter. So for the various values of the parameter, we can get the different shapes of the gamma distribution. Now, let's see one graph. So here I'm going to fix the value of lambda. So this is for the lambda is equals to 1, r is equals to 1. This is for lambda is equals to 1, r is equals to 2. And one more. So this is for lambda is equals to 1 and r is equals to 4. So here we can see that if we are fixed the value of lambda and we are increasing the value of r, so there is a decrease in the skewness. So this way the r is the shape parameter and lambda is the scale parameter. Now this gamma distribution is used to identify the amount of time until n events is completed. Now let's see the constant for the gamma distribution. So the mean of the gamma distribution is E of x is equals to r upon lambda. Variance of gamma distribution is r upon lambda square, and the standard deviation of gamma distribution is root r upon lambda. Apart from this, the gamma distribution is also generalized case for many probability distribution. So suppose if we put the value of r is equals to 1 over here, we can get the exponential distribution. So f of x is equals to lambda raised to 1 upon gamma 1, x raised to 1 minus 1, that is the 0, e raised to minus lambda x. So here this is nothing but lambda e raised to minus lambda x, and that is for x greater than 0, and this is nothing but the probability function for the exponential distribution. Now moving to the example. So it is given that in a certain city, the daily consumption of electric power in a million kilowatt hours can be treated as random variable having gamma distribution. So over here, the random variable x is nothing but the daily consumption of electric power in million kilowatt hours. Here the parameter lambda is given, that is the 1 by 2, and r is equals to 3. If power plant of this city has a daily capacity of 12 million kilowatt hours, what is the probability that this power supply will inadequate on any given day? So the power supply is inadequate on any given day is nothing but x greater than 12. That means your daily consumption is greater than 12 because the capacity is of 12 million kilowatt hours. So your daily consumption is greater than 12 million kilowatt hours, then only the power supply will inadequate. So the probability that power supply will inadequate is nothing but P of x greater than 12, and that is 12 to infinity f of x dx. Now f of x is equals to lambda raised to r upon gamma r. So lambda raised to r upon gamma r x raised to r minus 1 and e raised to minus lambda x. X raised to r minus 1 and e raised to minus lambda x for x greater than 0. So lambda raised to r, that is 1 by 2 raised to 3 upon gamma 3. Now here the gamma 3, so the value of r is nothing but the integer, so that is nothing but the r minus 1 factorial into x raised to 3 minus 1 e raised to minus 1 by 2 x for the x greater than 0, and that is equals to 1 by 8 upon 2 factorial, that is 2 x square e raised to minus 1 by 2 x for the x greater than 0. So 1 by 16 x square e raised to minus 1 by 2 x for the x greater than 0. This is your function f of x. So integration from 12 to infinity 1 by 16 x square e raised to minus 1 by 2 x dx. 1 by 16 is out of the integration 12 to infinity x square e raised to minus 1 by 2 x dx. Now the integration of x square e raised to minus 1 by 2 x is given by x square as it is. The integration of this e raised to minus 1 by 2 x upon minus 1 by 2 minus x square, derivation of x square is 2x, integration of this, so that is e raised to minus 1 by 2x upon 1 by 2 square plus in derivation of 2x is 2, e raised to minus 1 by 2x upon minus 1 by 2 cube. Upper limit infinity and lower limit is 12. So 1 by 16 x square e raised to minus 1 by 2x upon minus 1 by 2 minus 2x e raised to minus 1 by 2x upon 1 by 4 plus 2 e raised to minus 1 by 2x upon minus 1 by 8. Upper limit infinity, lower limit is 12. Now e raised to minus infinity, e raised to minus infinity and e raised to minus infinity is nothing but the 0. So 1 by 16 minus, let's put the lower limit, so 12 square and e raised to minus 6 upon minus 1 by 2 minus 24 e raised to minus 6 upon 1 by 4 plus 2 e raised to minus 6 upon minus 1 by 8. So 1 by 16 and e raised to minus 6 is common. Before that, just let's multiply with the minus. So 12 square is 144. E raised to minus 6 upon 1 by 2. Then plus 24 e raised to minus 6 upon 1 by 4. Then plus 2 e raised to minus 6 upon 1 by 8. So e raised to minus 6 upon 16 in bracket 288 plus 96 plus 16. So that is equals to 25 into e raised to minus 6 and that is equals to 0.062. So this is your final answer. So this is all about today's lecture. Thank you.